What's going on, everybody? Today we're going to talk about something like pretty complex, but we're going to break it down in a really simple way, and I'm going to leave a bunch of stuff out, but it's going to kind of get you started with what is called asynchronous programming. What asynchronous programming is basically with normal programming, you run one thing after another. So you write one line, that line is going to run before the next line, before the next line, before the next line. Asynchronous programming, as opposed to synchronous programming, which is what I just talked about. Asynchronous programming is when everything is kind of running at different times. You're creating new threads, which is kind of like the kind of very important bit of asynchronous programming. Essentially, you're creating new threads of execution that are all going to run at the same time as other threads of execution. So with a normal program, you're going to have one thread that runs everything synchronously, so one after the other. With an asynchronous program, your main thread is going to spawn new threads, 3 or 4 or 5 or 10 or 20, that are all going to run a certain operation at the same time as all of the other threads. And your main thread can even continue executing as well. So we're going to kind of see how that works in a very, very simple example. And I wrote a blog about this that talks a little bit more about the common pitfalls with asynchronous programming. I'm not going to talk about that as much in this video, so you can go and check out the blog if you want to know about kind of the things that can go wrong in asynchronous programming. But we're going to cover basically what asynchronous programming is and why it's really cool, how it can really help speed up a lot of the programs that you're running. So we're going to be using the async IO library. We're also going to be using time and date time to kind of track the runtime of all of these different things that we're about to do. So I've created two functions right here that we're going to look at. The first function is, well, the second function right here, let's talk about that one first. This is basically how you would run things normally if you just wanted to print a message out, to your console. So this right here is, it literally just takes a string in as input, it prints it out, and then it sleeps for a second. If we look up here, we're doing something fairly similar. We're printing the message out to the screen, and we're sleeping for 1 second. Now, as you can see, we're using a different sleep function here, but it functionally does the exact same thing. Now, we've got basically two main functions right here. We have our normal main, which is going to use the asynchronous function right here, the asynchronous print message function. And then we have synchronous, or the sync function right here, that is going to do the exact same thing. We're about to go over what this .gather function does, but it basically does the exact same thing, but synchronously. So it calls the synchronous function, the synchronous version of this. And if we look down here, our method of calling these is fairly simple. We're going to create a begin timestamp. We're going to run the synchronous version, and we're going to create an end timestamp. And then we're going to print out how long it takes. And we're going to do exactly the same thing with some different functions down here. So we're going to create a timer. We're going to run the main function, which runs the asynchronous version of our print message functions. And then we're going to track how long it took to run right here and print that out. So if we look at our console, let's go ahead and run it just to kind of show you the difference. We're going to see hello 0, 1, 2, 3, 4, 5. Now, if we look right here at this timestamp, it says synchronous run took 5.05 seconds to run. Now, logically, this makes sense in our head. If we look at this code right here, right there, we're going to call this print message underscore sync function with hello appended to the numbers 0 through 4. If we look up here, it is going to sleep for 1 second every time it's run. So in our heads, when we're running through this code, we're like, okay, this is going to be called 5 times, and it's going to sleep for 1 second every single time that function is run. The time that it takes to print out the message, the time that it takes to append a string to another string, those are going to take just a tiny fraction of a second longer. So that kind of accounts for this 0.053802 seconds right here. But in our head, we can basically say it makes sense for this to take 5 seconds to run. Now, let's look at this example right here, this asynchronous run. We basically get the same output. I messed up by not having a 0 here, but we basically get the exact same output, but it only took a little tiny fraction of a second over 1 second to run. Again, doing the same thing, but it's doing it asynchronously. Now let's walk through what we're doing here and how we're doing it. The main kind of meat right here that we're talking about, we can look at two different pieces of syntax here. First off, we can look at the function definitions. This is a standard function definition in Python. It uses the def keyword. It tells you the name of your function here, and then it allows you to pass in input variables within the parentheses. Very standard. Right here, we've got an added keyword, async. That added keyword is, just a Python keyword to tell you that this is an asynchronous function, which means that it's going to be run asynchronously, typically. So if we look down in our main function is also an asynchronous function. One of the important things to remember about asynchronous programming, I believe this is the same in JavaScript, but definitely in Python, if you are calling an asynchronous function within a function, the calling function has to be asynchronous as well. I'm 99% sure that it's the exact same way in JavaScript, but I know for a fact, obviously from looking at this, that it is like this in Python. We're going to get an error, I believe, right here. If we get rid of async, we've already got the red squigglies, and it's got an issue. This is because of this await keyword. Now, we're talking about a lot of syntax at once. These asyncs right here are just labels to tell Python that these are asynchronous functions, and we're going to be calling them differently from a typical function. This await right here is very, very similar to await in JavaScript, if you program in JavaScript. It's basically saying, wait for the result of this function, wait for the result of async.gather or asyncio.gather to continue. And obviously there's nothing after this, so our main function is going to return after this is returned. Now let's get into the meat of it. This asyncio.gather. Gather is a very common kind of pattern within programming. The basic way to understand it is we are going to do several things within these parentheses right here. We're going to do several things right here. And we want to wait for each one of those things to be done in order to continue. So basically what gather is doing is it is saying, hey, everything within this parentheses, I want all of it to be finished running before this function itself will return. So it can be kind of confusing, but if we look at this, just kind of like the way we've got it programmed instead of like very generally, we've got these different calls to print message, the async version of print message. So we've got essentially 5 calls to print message, and this is going to bother me, so I'm going to fix that. We've got 5 calls to print message right here, and each one of those calls is going to sleep for 1 second before it returns. So what this is doing is it's saying, start this one, don't worry about it returning. Start this one, don't worry about it returning. Start this one, don't worry about it returning. And at the very end, when all of these have returned, all of these are going to be run asynchronously. They're all going to be run at the exact same time. But once they are all finished returning, then we're going to actually return from the gather function. So basically, it doesn't really matter if this time.sleep were 1 second or if it were a dynamic variable. Let's say we can actually change this a little bit right here. So let's do sleep. Well, we're not going to call it sleep. Let's just call it S. And we are going to sleep for S seconds. And right here, let's just throw in 3, let's throw in 4, let's throw in 2, let's throw in 1, and let's throw in 6. Now, we're dynamically sleeping. We're going to sleep by a dynamic number every single time we run an iteration of these function calls. So let's go ahead and run it this way. I actually haven't tested this out. I'm really hoping that it works. Let's run it. We get hello 0, hello 1. So this is running the synchronous version of this first, and then it's going to run the asynchronous version. Now, as we can see, it's taking a little bit longer. Why is it taking a little bit longer? Well, it takes approximately 6 seconds to run. Let's look at our function calls. So our function calls right here, it prints everything out immediately because the print comes before the sleep. If we look at it right here, the print comes before the sleep. So we know that all of these functions are getting called at the exact same time. But gather waits for all of the functions to be finished returning in order to actually return from the gather function and to continue and finish the main function. So if we're looking here, we're kind of wondering, okay, well, why did it take 6 seconds to run? Well, we see right here, we've got a print message call with 6 in the parentheses. That is telling it to wait for 6 seconds. And if we look at all of the other calls, there is not another call that is longer than 6 seconds. So 6 seconds is the longest sleep time that we're going to have in all of these function calls. If we change this to 8, then it would take 8 seconds for the main function to finish because gather waits for all of the functions to finish. So by the time we're sitting here waiting on this last function call to finish, all of these right here have already finished their sleep functions. We're still waiting on this one to return so that we can return from the gather function and then return from the main function. So this is very, very important to understand that essentially when you're using the gather pattern, whether it be in Python or in JavaScript or anything like that, your runtime is essentially going to be as long as the longest call within that gather pattern. So within this gather right here, this gather is going to take as long as the longest call to these functions. When everything was just one, when we just had 1 second, this was a static variable right here, or a static input, just one, then obviously they were all going to finish at the exact same time, because a sleep for 1 second is just as long as another sleep for 1 second. But since we use this dynamically instead, then basically this is going to take as long as the longest call to this function. So like I said, this is a very, very simplistic introduction to asynchronous programming. Asynchronous programming is a phenomenally complex problem that a lot of people with way more experience in computer science than I have could probably teach you a little bit better. There is a blog, like I said, that I wrote that talks a little bit about the pitfalls and kind of the common things that go wrong when you're trying to program asynchronously. Go and check that out if you kind of want to get into more asynchronous programming or want to apply it to a problem that you've got. And that will kind of help you understand what can go wrong and the things that you need to avoid when doing asynchronous programming. That's about it. Take it easy, y'all. I hope you enjoyed this. Peace.